So we're continuing with paper 2 of the 0625 IGCSE Physics specimen paper from 2023. It covered up till question 15, so 14. So let's continue with question 15 today. A substance can exist in 3 different states: solid, liquid, or gas. Each of the 2 statements below describes a change of state. Change 1: particles move much closer together but continue to travel throughout the substance. And change 2: particles stop traveling throughout the substance and just vibrate about their fixed positions. Which
B.
changes? Huh?
B.
Yes. Right? So they're
B.
close, so they're turning from gas to a liquid, so that's condensation. And change 2 is that they're not moving throughout, there's vibrating in the fixed position, so that's going from liquid to solid, and that's solidification. Alright, copper is a type of metal. A block of copper has mass 2 kilograms. The block of copper absorbs 12,000 joules of thermal energy. The specific heat capacity of copper is 385 joules per kilogram degrees centigrade. What is the temperature rise of the copper? Now, do you remember the formula?
I think so.
What is it?
Uh, Mass. Oh, it was. Oh, you have to use the capacity formula, I guess. Wait. This one. Oh yeah. Okay. It's that one.
Hmm.
Joules equals to uh mass over J, if I'm not wrong.
Wait, what?
We have to uh we have to like do 12,000 over. Wait. Is it 15.6?
Yeah, how do you do that?
No. We have. Can I use the signs that we have for the formula?
Yeah.
Okay. So we have Q as 12,000
Mm,
and
Q is
M
12,000?
12,000 joules.
That's E, right? But E for energy.
Yeah.
Yeah, not Q.
Okay. Yeah. Sorry, my bad. And then we have 2.0 as the mass,
Hmm.
and then we have 385 joules, or you can right here, or in kgs for C.
Hmm.
So with that, we have to do 12,000 divided by 2.0 multiplied by 385,
Yeah.
and then so 2.0 multiplied by 385 is 770. So 12,000 divided by 770 is 15.58. So if we round it off, that's 15.6.
Yeah. Good. So as I showed this page earlier, I don't know if you took a look at it, right? Delta E equals to MC delta theta, right? The change in energy is equal to the mass multiplied by specific heat capacity multiplied by the temperature rise. So you obviously moved it about, And so you get delta theta, which is the temperature rise, is the energy divided by mass times specific heat capacity. Right, and so you get 15.6 degrees centigrade, which is correct. Okay. Question 17, the diagram shows the gap between a hot surface and a cold surface. The gap can contain air, iron, a vacuum, or water. Which material in the gap allows the quickest transfer of thermal energy between surfaces by conduction?
What was conduction again?
Conduction was the transfer of heat energy without movement of the material itself.
Okay. So it wouldn't be uh air.
No, it wouldn't.
We would eliminate that. Neither would it be D.
Good.
So A and D are removed. Vacuum has no particles, so it's definitely that is removed as well.
Yes,
So it's B.
it is B. Good. Good approach. All right. Which row about boiling and about evaporation is correct?
D?
Are you sure?
No, wait. Let me just give me a minute. Yeah, it is D.
You do. Okay. Are boiling and evaporation the same thing?
Yeah, no.
Right? Then how do they have the same, feature? I mean, it is possible that some features overlap. True, you could argue that, but I'm telling you it's wrong.
So it's not D. Okay. So if they don't have the same features, then A and D would be eliminated.
Yes.
Okay. Mm, B?
No.
Well, then that
Only
leaves us
the
at,
C.
yeah.
Yes. And so to recall, right, boiling is a change of state. It is a temperature at which the entire liquid undergoes a change of state. It happens throughout the liquid. The entire liquid, the particles, the molecules, or whatever it is, right, gain enough kinetic energy that they're changing from liquid to gas. That is what boiling is. Evaporation only takes place at the surface, right? It's only the molecules at the surface that gain enough energy to escape the surface of the liquid and turn into vapor, right? And so it can happen below the boiling temperature, whereas boiling only happens at the boiling temperature. You can have evaporation happening at room temperature. You might obviously must have noticed multiple times you have like a wet cloth, or even if your hands are wet, right, sweat perhaps, and it's not boiling, your skin's not boiling. Obviously you wouldn't be around if it were, but right, the sweat dries off, the water dries off the cloth, right? So it's
Yeah.
obviously the water is turning into vapor much below boiling temperature,
Yeah.
whereas boiling, as the name says, it only happens at the boiling point.
Okay.
All right, question 19. Light travels at a speed of 2 into 10 to the power 8 meter per second in a glass block. In the glass, the wavelength of light is 4 into 10 to the power minus 7 meters. What is the frequency? Do you remember the wave equation?
Yeah.
What is it?
Oh wait. We have to use the speed equals to frequency multiplied by wavelength, right?
Good.
And we have to rearrange that. So that would
Yes.
we have to find the frequency here.
Yes.
So if we make the frequency the subject, that would give us frequency equals to speed over wavelength.
Yes.
Okay, so our speed here is 2.0 multiplied by 10 to the power 8 meter per second and divided by the wavelength, which is 4.0 multiplied by 10 to the power minus 7 meter. And we do that. Just a second, I'll calculate. Would that give us uh that give us 0 or 0.5 over 10 to the power 15?
Why are you making it 0.5 into 10 to the power minus 15? Why can't you write it as 5 into 10 to the power 14?
Wait, is it we're gonna do 2 point are we gonna do the coefficients first, like 2.0 and 4.0?
Yes, but you also need to adjust the powers and you want a whole number, don't you?
Yeah.
I mean, if you're getting 0.5 into 10 to the power 15, does it match with any answer?
No,
But if you just move the decimal around and you adjust the power 10,
that would be 5.0
yes,
multiplied by 10 to the power 14
yes.
hertz. So that would uh, give us the option D.
Option D, yes.
Okay, let's move to the next question.
Huh. I actually downloaded a scientific calculator app for my mobile. I'm trying to
Okay.
figure it out. Anyway, right. So D is the answer for 19. In a shallow tank, a water wave moves through a barrier with a narrow gap. The diagram shows the waves on the left hand side and the right hand side. What is this effect?
Hmm. It wouldn't be reflection.
It's definitely not reflection.
Um, Not refraction as well.
Not refraction either, because refraction is a bending and it's not bending. Right? It's a change in direction. You just
So A
back
and C are out.
A and C are out. Good.
It wouldn't be dispersion as well, would it?
No, it wouldn't.
So it would be diffraction.
It is diffraction. Good.
Okay.
All right. Which statement describes monochromatic light?
Ooh, that one is hard. Wait. Wait, I think we learned that in the wavelength chapter.
We did. I mean, the waves unit, that's what we
Yeah,
meant.
yeah.
Yes.
It's not A.
It is not A.
Can wavelengths can pass through glass prism?
Can wavelength pass through glass prism?
It
What do you mean?
says light that spreads out when shown through a glass prism.
Yeah, so
So
we're talking about dispersion, right? We're talking about dispersion of light.
okay,
And what we talked about in the text is like in the syllabus is when white light is passed through a prism.
and then it shows the rainbow.
Yeah, because the wavelength, is different, and so each of the lights refracts differently, and so that's why it separates. But you're talking about monochromatic, so it's only one
Yeah.
light, so it's not going to spread out further, is it?
You say it's one light, so it has light that has single frequency.
Yeah, and so and obviously a single wavelength, and so right, is there anything to spread out?
No.
No, so it's not C either.
Yeah. Okay. And D is it wouldn't be D as well, since the speed of light changes depending on the material it travels through.
Good, right? And plus light that travels at the same speed in all materials, so yes, right, it depends on the material. Well, yes, your reasoning is correct. I was thinking of it differently, but that doesn't apply over here. uh, right, all the frequencies, like all the different colors of light have the same speed in a single material,
Yeah.
right? So not in all materials. So
A
then,
monochromatic light, I do have an example for that. May I?
yeah,
In labs, they use lasers, so that could be an example.
yeah. So light mono, look, mono means one. You should know that from
Yeah,
chemistry,
yeah.
and chrome means color.
Oh,
I I
okay.
I believe it comes from the I don't know, Latin or Greek word that's chroma, which means color, right? So monochrome means single color, monochromatic, so that's like adjective, right? A single
So
colored light.
one color light.
Yeah, so you have a light that's only green or only blue or pink or whatever, right? Only yellow. So that's monochromatic light. So you eliminate A, C, and D correctly, which leaves you by elimination with B,
Yeah,
right? But you should also remember that the syllabus has taught you that the color of light depends on the frequency of the waves of that light. So it is frequency which determines color,
yeah,
right?
yeah,
So I think you didn't catch that immediately because you weren't sure about monochromatic light.
yeah, yeah.
Yeah. So
I
now,
had to recall like words and that.
right? So monochromatic means single color. Okay. So
Yeah.
D is the correct answer.
Okay.
All right, an object is placed 8 centimeters from a thin converging lens of focal length 5 centimeter, right? So, which statement about the image formed by the lens is correct?
Hmm. Let me see. A.
A is correct.
Yeah, my gut says that.
Just your gut?
Yeah.
What's your reasoning?
I mean,
I mean, it's okay to go with your gut if you're not sure, but right, we're preparing, so we should know how to reason this.
uh, let me wait. Actually, you know what? It's better if you.
So, right, the focal length, right, and the object, if the object is placed at the focal length or further away, then it's going to form a an in a real image, right? And a real image is always inverted. The only time when it's going to form a virtual image, right, if the object is placed clo- you know closer than the focal length. Okay, so if the
Yeah.
object were placed at a distance less than 5 centimeter, then you would have gotten a virtual image, and a virtual image is always upright.
So it was less than 5, then it would be D. But since it's the length of the object is more than the focal point, then the image is real and inverted.
Yeah.
Okay. Okay, yeah, that makes sense. Okay.
All right. A ray of light travels through transparent plastic to air. The ray of light enters the air traveling parallel to the surface. So, what situation are they talking about?
Hmm. We have to find the angle at. I forgot what that sign is called.
Theta.
Theta?
Theta.
Theta. Okay.
Not theta.
Yeah.
Theta.
Okay. We have to find that angle. Okay.
Yeah, but I'm asking what situation are they showing over here?
Yeah, they're showing that the light travels through the transparent plastic. I mean, is it bouncing back, right?
It's refraction. It's not bouncing back, but it's refracting a- along the surface of the plastic. It's refracting.
Oh, it's bending. Yeah.
Yeah, it is refracting at 90 degrees to the surface, like the normal, not the surface.
Okay. Yeah.
So, if you recall refraction, what is this phenomenon called?
Uh, wait. Are you,
I'm
the
I'm
wait
I'm
for the form?
asking you because that is relevant to solving the question.
I do know that we are gonna solve this with Snell's formula, if I'm not wrong.
And what is that?
Right? Am I correct?
What is Snell's formula?
Uh, can I say with the signs
Yeah.
N1 sin and theta in the brackets with one at the bottom? Am I correct?
No.
Equals to. So I remember, but I don't know how to explain it. Can I say it in the chat? I know the formula, but I can't like say it verbally. I don't know how to write it though.
So, refraction of light, the situation that we are dealing with is called the critical angle.
Wow. That was for sure critical.
right? And the critical angle is, right, when the angle of incidence is such that the angle of refraction is 90 degrees to the normal of, right? So part B. And so when you are, this is just before, if you increase the angle of incidence any further, you get total internal reflection. But that's not what's happening over here. So to calculate the refractive index and critical angle, you use the formula.
Look, yeah, that's what I was talking about.
Okay, you were saying something like that, n
Yeah,
tan theta and
yeah,
sin.
yeah.
Okay. So, right, the refractive index is 1 over sine of the critical angle, right?
Mm-hmm.
So you have the refractive index, right? That means 1 over refractive index, and then you take a sine inverse. So 1 over 1.25,
Which gives us 0.8.
and then you take a sine inverse,
Yeah.
which gives you
Wait. 53.13.
53.13. So which of the answers are you picking?
D.
Yes.
Okay.
Right. Question 24. What is the speed of electromagnetic waves in vacuum? Now, there's the problem over here, isn't it?
Right.
What is, okay, what is, like, forget the options.
Okay.
What is the speed of electromagnetic waves in vacuum? Just tell me without looking at the options.
Wait. 1,000?
Seriously, are you guessing?
Am I?
Yeah, you're just guessing like 1,000? Seriously?
Is it correct?
Not even close. I mean, if it's 1,000, then like, what are you going to do with the options?
Wait, wait.
This is like a
Okay.
this is like a fact that you need to know.
Um, three. I have it in mind, but the option is not there.
Yeah, like that's what I told you. Forget the option. Tell me what's in your mind.
3 multiplied by 10 to the power 8 meter per second.
Meter per second. Good. Now these are given either as kilometers or centimeters.
Yeah.
Right? Kilometers are larger units than the meter. Right? 1 kilometer is 1,000 meter. And so if you were going to convert 3 into 10 to the power 8 meter per second into kilometers, what would you do?
Divide
By how much?
10 to the power 3.
By 1,000, right?
Yeah.
Yeah, so what would that give you?
Just a minute. Let me count. 3.0 would be the same
Yes,
multiplied by 5. 10 to the power 5.
kilometers per second. Do you have that option?
Yes, which is B.
Yes. Now, just to check, if you were going to convert the meter into centimeter, what would you do?
Meter into centimeter.
1 meter is 100 centimeters.
Yeah.
So, if you were going to convert it into centimeters, what would you do?
Multiplied by 100.
Yes. And so, what
Uh,
would that give you?
Wait, what were the values again?
3 into 10 to the power 8
And we have to do that into meters.
into centimeters.
That will give us 3.0 multiplied by 10 to the power 5. Yeah.
Into centimeters, you multiply it by 100.
Oh, okay. Sorry. That would be this. 762 centimeters.
What are you doing?
I think I forgot how to do centimeters. Wait.
Look, to convert 3.0 into 10 to the power 8 meter per second to kilometer, you divided that by 1,000, right?
Yeah.
And you got an answer that matches one of the options, and it's the correct answer,
Yeah.
right? Just for verifying, for the sake of verification, I actually converted to centimeters. And so simply you multiply 3 into 10 to the power 8 meter per second,
Divided by.
not divided by, multiplied by 100.
Okay. Multiplied by 100. 100, right?
Yeah.
That would leave us with 3,000 something. There are too many zeros.
3 into 10 to the power 10. Okay.
Yeah.
Do
Yeah.
you do you
Yeah.
have
Yeah.
do you have that option here?
No.
Obviously. Now, if you were to make the mistake which you were about to make just now of dividing it by 100
Then
instead of
that will give us the wrong answer.
that would give you option C.
Yeah.
And so then you would have two correct answers, and that would confuse you,
True. Yeah.
right? And it is for the fact that they've given that option means that there probably are students who would be making that mistake.
And the invigilator had put that question on purpose to confuse
The
the student.
examiner, they've given that option, yes, right? So you have to be careful about what you're doing. If you
Yeah.
do it correctly, it's not even close.
Yeah.
Okay, a pulse of sound is produced at the bottom of a boat. The sound travels through the water and is reflected from the seabed. The sound reaches the boat again after 1.3 seconds. The seabed is 1,000 meters below the boat. What is the speed of sound in water?
We have to use the speed formula here.
Yes, you do.
So speed equals to total distance over total time.
Yes.
So wait. So are we gonna multiply 1.3 multiply by 1,000?
Why are you multiplying?
That's the total time, and the depth is 100. Sorry, 1,000.
The depth is 1,000, so that's the distance,
Okay, that's the distance. Yeah.
right? Speed is distance over time. So 1,000 divided by 1.3. That's what you're saying.
Yeah.
What are you getting?
I'm getting. Wait. Is it? Wait. 769.230.
So which option would you pick?
If we round it off, A?
Okay, as per your
Because,
calculation, that would be the option you choose, but it would be wrong.
yeah.
Why?
It can't be 770. I mean, isn't that too less?
Okay, that's not an argument over here, right? You think it's too less, right? It's not like you're going to the store and you're like, why is this so cheap? There's got to be something like, there's a defect or something. And that's not the argument. Okay? The
Yeah.
the argument over here is the total distance between the boat and the seabed is 1,000. The sound being generated from the bottom of the boat has to reach the seabed, so that's 1,000 meters. Then
Yeah.
it's reflected and it comes back to the boat, so that's another 1,000 meters. The total distance traveled by the sound in 1.3 seconds is how much?
2000?
2,000.
Oh, so 2000 divided by 1.3.
Yes.
Oh my god. That would give us. Whoa. If we round it off, 15. Option C?
Yes.
Okay.
Right, so 1,500 meters per second would be what you'd be selecting as your answer.
Yes.
Okay. A sheet of ice floats on water. A source of sound is positioned at the edge of the sheet. Four microphones are placed equal distances from S. Which microphone detects the sound first?
Wait, which microphone detects the sound from S first? Okay. B?
Why?
Because it's much closer than to S than the other microphones.
Four microphones are placed equal distance from S.
Equal distance. Oh, wait. But sound travels more quickly through solids
Hmm.
than the A is in air,
Yeah,
D is in like above the water, if I'm not wrong.
it's
And
like halfway. So
yeah, and water and the C microphone is in underwater.
okay,
But speed travels differently through air.
sound has different speeds in different media,
Yeah,
right? It travels fastest through
solids.
solids. So
So ice is a solid, so it travels faster. And B is there near the solid. So
very good,
yeah,
very good. Okay,
enough.
really? Okay, you know what? We have done until question 26. We've got 13 questions left. We did a little less today. We did 12 questions, I believe. Yesterday we
Yeah.
did 14, so we've got 13 left. We should be able to complete them in next class, but not further. Right? So we'll be done with paper one the next time. So okay, let's stop here if you're right throwing in the towel for today. And I'll see you next time, inshallah.
Inshallah. Okay. Allah Hafiz.
Allah Hafiz.